We're going to be doing notes 5.1, solving quadratic equations by factoring. Look at me. I was in such a hurry. Factoring and square roots. And so part 1, we're going to solve by factoring, which is review. Okay? In fact, we just reviewed a little bit of it when we did our solving the radical ones. Remember when we squared it out into factor it to finish? All right, so that'll be, we've already got a head start on our review. All right, so I just want to run through the steps as a refresher. All right, first of all, what do I mean by a quadratic equation? Okay, x squared plus x, okay, so it's got an x squared in it, that's the main thing, okay? So the first step is to make the equation, because it's an equation you're solving, equal 0. All right, so that you have something like ax squared plus bx plus c equals 0. Okay, that's standard form. So you're going to make it equal to 0 if it's not already. Go away, block. Okay. We're okay with that step. All right. Second step, factor. Now, there's lots of techniques for factoring, right? But you should always look for what first? Remember? Always look for GCF first. Okay? Always look for GCF first. All right, and then you would move on to whatever the appropriate method is. Okay, so what methods am I talking about? Well, normal unfoil, which is what we reviewed with when we happened to be solving radicals. That came up. But there's also the AC method, and there's dots. Okay? So we're going to review a little bit of each today. All right, and then once you factor, you're going to set each factor to 0 and solve. And then you can always check. You can always check. Okay? All right, you ready? All right, so let's do some practice. Again, we're just solving by factoring. What do you guys think is the first thing we need to do? GCF. What is it? 4x. Good. And it's not disappearing. It's got to stay there. It's one of our factors. All right, then what's left? X, what? Minus 2. Perfect. Okay. Now, is anything squared anymore? No. So I'm done factoring. I'm done factoring. What's the next step? Set each factor equal to 0. What's the next step? Solve. All right, that means get x by itself. How do I solve that first one? You divide by 4. And I know why you're saying you don't, and I'm going to review that in just a second. You divide by 4, and you actually do get x equals a number. But if it were just regular 4 equals 0, there's no x, then you're right. You can't solve it because there's no x. That's the kind you cross out. But if it has an x, you got to solve it. Okay? And then the second one, what do you get? X equals 2. All right? Now, how could you go about solving? Like, how do you check this thing? All right, you plug 0 in for the x's all at one time, and then you go back and you plug 2 in for the x's all at one time. Take it down into Desmos if you know, to do this. I'm not going to spend the time here, because most of the time, the check here is really just to make sure you did it right, because you're not going to get a no solution on these. Okay? All right, let's do another one. 7x squared plus 8x equals x squared. All right, I want you to try this one on your own. Remember, it has to equal 0 first. That first step. What did you do with the x squared that was on the right? Subtract it. And remember, there's one of them, right? You're subtracting 1. All right, so we get 6x squared plus 8x equals 0. Now you can go through the factoring process, which starts with greatest common factor. All right, I want to know what you got, and then if we didn't get the right answer, we'll go back and look at it. Positive 4 over 3 or negative? Negative. Very good. All right, so then let's go back and look at it. All right, what is the GCF? 2x. What's left? 6 divided by 2 is 3x plus 4. So, give myself a little bit more space here. So I've got to set the 2x equal to 0, and that one does give me x equals 0. But then when I set the 3x plus 4 equal to 0, I've got a minus 4, then divide by 3. We okay now? Bless you. Okay? Good? All right, number 3. 9x squared minus 25 equals 0. Does this one have a GCF? No. No. Is it a trinomial? No, it doesn't have 3 terms. So if there's only 2 terms, what should you be checking for? Dots. Dots. Right? All right, dots is the difference, so it has to be subtraction, of 2 squares. Okay? Difference, is it subtraction? Of two things, squares. Are they square numbers and letters? Okay, so if you have a dots, it unfoils. So that means you're going to set up your double parentheses. And you are literally going to take the square root of each piece. All right, so the square root of 9 is 3, and keep an x with it, right? You cut the letters in half. And so that means a 3x is going to go in front of each. And then the square root of 25, so 5 is going to go in the back of each. And 1 positive and 1 negative. Does anybody remember what we call it when we have a binomial times almost the same binomial? One's a plus and one's a minus? Start with a C. Conjugate. Conjugates always give you dots. Okay? So now you should be able to set each one equal to 0 and solve. So take a second and do that, please. All right, what'd you guys get? And positive 5 over 3. Very good. Anybody need to see the work? All right, now I already wrote number 4 up here. So this one is like the type that we have already reviewed. like earlier today and in the last unit, when we're back to a trinomial, and all we have is that x squared in the front. Yep. Yes, that's a 21. It's just a sloppy 21. Sorry. So when I use the software that I'm using, the smartboard software stuff, the pen doesn't work, so I have to use my finger, and I get a little sloppy. All right, so remember with this kind, you break the letter up in the front of each, and then you ask yourself, what multiplies to be the third number, but adds to be the middle number. So I need something that multiplies to be positive 21, but adds to be a negative number. So both negative, 7 and 3. Does it matter which one I fill in first? Nope. Now, remember, this is, like the solving part where you set each one equal to 0, if you can do that in your head, you don't have to write that step out. All right, what are we going to get? Positive 7 and positive 3. Okay, questions on that? All right, let's move to another page here. All right, this time I'm going to do 2x squared minus 2x equals 24. I'll give you a minute to do that one on your own. Remember, has to equal 0 first. What would you guys do first? Perfect. Subtract 24. Now it's a trinomial, but it has GCF of 2. Careful, 2. If we take out an x, we're going to mess up our pattern of a quadratic function. Plus the 24 doesn't have an x. All right, now can we unfoil this thing? Yeah. All right, what multiplies to be negative 12 and adds to be negative 1? Awesome, negative 4, positive 3. All right, so Tyler, this is one that you were talking about earlier, where if I set each factor equal to 0, if there's no x, I just cross it out. Okay, if there's no x, I just cross it out. What'd y'all get for your other answers? Good. Perfect. All right, now we're going to bump it up. So we've just reviewed unfoiling, GCFs, and dots. What's the other thing we got to review? Do you remember? AC method. So close with that ABC. Okay. The AC method. So first we have to talk about why would we even need it. All right. Like, how do you know you need that AC method? Say that again. You have no clue. Oh, okay. Well, it's a trinomial, so it still has to be a trinomial. But even if I could take out a GCF, all right, there's still a number in front. If there is still a number in front of x squared, and I can't take it out as the GCF, then I have to use the AC method. Okay, so let's review the AC method. It literally says take the A number times the C number. That's how it gets its name. And write it down. And now you need a pair that multiplies to be your new number and adds to be your middle number. Has to multiply to be negative 90 and add to be negative 13. Well, this was a little bit harder. So let's just work our way through what would give me 90, and if you work in order, you'll eventually find it. All right, 1 and 90, and it doesn't matter which one I make negative, am I going to get negative 13 when I add them? All right, how about 2 and 45? No. How about 3 and 30? How about, I don't think 4 works. Nope. How about 5 and 18? Yeah, if I make one of those negative, I'm going to get a negative 13 out of it. Which one needs to be negative? The 18. Okay? But this is also the kind that does not go straight to double parentheses. This is the kind where you have to go from 3 terms to 4 terms using your pair. Okay? So we need a positive 5. What else has to go with that 5? An x, good. And then a negative or minus 18x. Starting to come back to you? What happens when you have 4 terms? Put that line down the middle, we call that grouping. No, it does not. No. In fact, on my paper, I put the negative 18 first and the 5 second. So as long as the 18 has the minus sign and the 5 has the plus sign. All right, so how does grouping work? What do you have to do? Look for the GCF in each group. All right, now, again, you did not have to do it in the same order as me, but what is my GCF in the first half? X. What's left? 3x plus 5. So remember, I need to find something in the other pair that when I take it out, I absolutely should be left with a positive 3x and a plus 5. That's the whole point. What can I divide by? A negative 18 and a negative 30. 6, but I need to change their signs, so I need to take out a negative 6. 3 is a GCF, but it's not the greatest. I mean, it's a common factor, it's just not the greatest common factor. Okay, so now we're ready to do our double parentheses. What's going to go in one of them? X minus 6. What's going to go in the other one? Does it matter which one I write first? No, it does not. Does everybody remember where those things just came from? Okay? And now you need to set each piece equal to 0. All right, what'd y'all get? 6 and negative 5 over 3. Perfect. Anybody need to see any more work? All right, let me give you one of those to practice on your own. So number 7, 4x squared minus 11x equals x minus 9. What are you going to have to do first? Correct. You have to move everything to the same side. It has to equal 0 before you can ever even think about what kind of factoring it requires. Okay, so take a second and do that, and then decide. Hopefully you decide it needs the AC method. All right, so let's run through this last one. It does equal 0 now, right? Hopefully we all got that. And then you use the AC method. What was your A times C number? 36. And I needed 2 numbers that multiply to be 36, positive 36, but add to be negative 12. All right. Be careful, they both do need to be negative, because 2 negatives are the only way to multiply to be a positive in this case. Okay? So when you set up your 4 terms, you need negative 6 and negative 6x. Okay? And then hopefully you factored by grouping. And let's see. You should have a 2x in common. leaving you with 2x minus 3. And then you need to take out a negative 3 so that you also get 2x minus 3. So remember, whatever's in the parentheses should match, and that's going to be one of your factors. And then the pieces, the GCFs that you took out, go together to make your other factor. We happen to get the same factor twice. So how many times do we have to solve it? Once. If you already know it's going to be the same thing, you just need to do it one time. What'd y'all get? Good. Good. That's the end of part 1.